Okay, so let's have a look at example 1. Person standing on the top of a 35-metre high cliff and they throw a stone into the water with a velocity of 16 metres per second at an angle of 30 degrees. Here it is, 35 metres high. Whoosh, there it goes. So I instantly know the following. I know that the velocity is equal to 16 and I know that theta is equal to 30 degrees. Now, when we're doing these sorts of questions, we always need to start with the same thing. We're going to start with horizontally. What's happening horizontally? Now we know the horizontal acceleration. The horizontal acceleration is always 0. When you integrate 0 with respect to t, you'll just get a constant. We also know what happens at time 0. At time 0, the horizontal velocity is equal to v cos theta. We found that's the very first thing we did on this particular topic, which means if you substitute that in, you find that c equals v cos theta, so the horizontal velocity is equal to v cos theta. But we know, if we look up here, what v is and what theta is. So I can come back and I can go, well, that's actually equal to 16 times the cos of 30, which is 16 times square root 3 over 2, because that's what the cos of 30 is, which is 8 square root 3. Now the next thing I want to do is not to get rid of, is to find the horizontal displacement. So I'm going to integrate. Integrate 8 root 3 and I'll get 8 root 3 t plus c. But with this particular question, we know at time 0, it has an x value of 0 because it's on the y-axis, and on the y-axis all x values are 0. So we say when time equals 0, x equals 0, and if you plug that in, that will actually give you c equals 0, which means x is going to equal to 8 square root 3 t. So I now have 3 formulas. I have my horizontal acceleration, my horizontal velocity, and my horizontal displacement. That's horizontally. I need to deal with vertically as well. So let's deal with vertically. So vertically, I know that my vertical acceleration is equal to minus 10. When I integrate both sides with respect to t, I'm going to get my vertical velocity equals minus 10t plus c. Now remember, I chose minus 10 because it says up here, let g equal 10 meters per second squared, and we're not worried about any air resistance. Now, I know when t equals 0, that y dot, my vertical velocity, equals v sine theta. That was the very first thing we did, the very beginning of this booklet for this topic. And if I plug in t equals 0, y equals v sine theta, that gives me c is equal to v sine theta. Which means that the vertical velocity equals minus 10t plus v sine theta. Now we know what v is and theta is. V is 16, theta is 30. So let's plug that in. That equals minus 10t plus 16 sine 30. Now we know the sine of 30 is a half. 16 times a half is 8. And there is our statement. So I've got my vertical acceleration. I've now got my vertical velocity. I need to integrate this again. So if I integrate this again, I get y equals minus 10t squared over 2, which is minus 5t squared, plus 8t plus c. But this is where you've got to be careful for this question. At this point here, when time equals 0, y is equal to 35 because we're not starting on the ground. So we need to remember that. So for this question, when time equals 0, y equals 35. And if I plug that in, I get 35 equals c, which means y will equal minus 5t squared plus 8t plus 35. And there is my sixth equation. So I now have my horizontal and vertical acceleration, velocity, and displacements. Let's look at part B now. Part B says derive the Cartesian equation of the stone's flight as a function of y in terms of x. Now remember, that's just a matter of looking at our x and y values and doing some substitution. Now if I look at this one here, I can see that I'm going to substitute the rearranged version of x equals 8 root 3t into y. So let's try that. So, since x equals 8 square root 3t, t is going to equal x over 8 square root 3. Let's substitute that into y. Let's substitute it into y equals minus 5t squared plus 8t plus 35. So I get y equals minus 5. What is t? It's x on 8 root 3 squared, x on 8 root 3 plus 35. Now when I look at this, I'm going to get minus 5 x squared over, now 8 eighths are 64, square root 3 times square root 3 is 3, and 64 times the square root of 3 is 192. Plus, when I look at this next part, the 8's cancel, which leaves me with x over square root 3 plus 35. And that'll do. That's your answer. That's your Cartesian equation of y in terms of x. Okay, so let's look at part C now. It says to calculate the time that the stone will take to land in the water. Okay, so we actually have here a formula, and that's going to be handy because the time the stone will take to land in the water, when the stone lands in the water, let's come back to our diagram, at that point where it hits the water, its y value is 0. So we're going to use that to our advantage. So we can say to land in the water, y is equal to 0. Now if y is equal to 0, that means that we can actually use this formula here and put 0 equals. So we'll substitute it into that formula and we can say 0 equals minus 5t squared plus 8t plus 35. Now you could try solving this using numbers, to times to give this and add to give that, but the fastest way is going to be the quadratic formula, especially if it's not a neat answer. So minus b plus or minus the square root of the b value squared minus 4 times a times c all over 2 lots of a. Let's put that into the calculator. And we put that into the calculator, we get t equals, so we'll do it for the positive case, and we'll do it for the negative case. And we'll get for our two answers minus 1.96 and 3.56, which means the answer is 3.56 since time has to be positive. So 3.56 seconds to land in the water. When t equals 3.56, question says, remember, calculate the time the stone will take to land in the water and its distance from the foot of the cliff. We're going to use this formula here for its distance from the foot of the cliff because from there out to there is an x direction. So if at time equal 3.56, which is, lands me in the water, that'll give me the x value as well. So I can go t equals 3.56, x equals 8 square root 3 times 3.56. Put that into the calculator and I'll get 49.38. And so effectively what we're saying here is it's going to take 3.56 seconds, or just over 3.5 seconds, for the stone to hit the water, and it's going to land 49.38 metres out from the bottom of the cliff. So there's our first example sorted. Let's go on to our final example, and the final example for the course. Not just this chapter, for the course. Now there are plenty of other questions you can do, but at this stage, this is where we're at. Now, let's go through this process. We'll read the question first. A softball player hits a ball at a velocity of 30 metres per second. The ball just clears a 1.5 metre fence, there it is, which is 80 metres away. So the ball goes up and over the fence just, and it lands on the ground. We need to find the angle at which the ball was hit. Well, this is a little bit more challenging, but we're going to start the way we've started with all the other questions. We're going to start first of all with the horizontal case. So, horizontally, we know horizontally that our horizontal acceleration is 0. We know if we integrate that with respect to t, we'll get c. But we also know at time 0, the horizontal velocity is v cos theta, which means c equals v cos theta, which means x dot, or the horizontal velocity, will equal v cos theta. Now remember, with this question, we know that v is equal to 30 meters per second. So we can actually plug in v equals 30 and we get our horizontal velocity equals 30 cos theta. Now let's integrate that again. X will equal 30t cos theta plus c, and we know when we look at this question that at time 0 x is 0 because we're starting at 0, 0. So, but at t equals 0, x equals 0, and if I plug those in, I'm going to end up with c equals 0, so x equals 30t cos theta, and that's my formula. So I'm going to park that one there in this box because I want it to stand out. Let's now go to the vertical case. So vertically, we know our vertical acceleration is the acceleration due to gravity, which is minus g, but I'm not going to use minus g. I'm going to use not minus 10, I'm going to use minus 9.8 because the question tells me to use 9.8. So minus 9.8. So if I integrate that, I'll get the vertical velocity, which is minus 9.8t plus c. But at time 0, the horizontal velocity is v sine theta. We did that the very first thing we did, remember. So if I put in t equals 0, I get c equals v sine theta, which means the vertical velocity will equal minus 9.8 t plus v sine theta. But I know v for this question is 30. So it becomes minus 9.8 t plus 30 sine theta. Now, question is, do I have any more information that I can use? Well, not really. I don't know the angle that this is shot off at. That's what I'm trying to find. So let's go and find the value of y by integrating again. Now, 9.8t, when you integrate it, will give 9.8t squared over 2. And when you do 9.8t squared over 2, that'll end up being minus, nearly forgot the minus sign there, minus 4.9 t squared, because 9.8 over 2 is 4.9, plus, we're integrating with respect to t, so 30t sine theta plus c. But at time 0, we know at time 0, its y value is 0 as well. And if we have at time 0, the y value is 0, it means c will equal 0. So y equals minus 4.9 t squared plus 30t sine theta. So there are our two equations that we generated from scratch going through the entire process. Now, I want to look at this one here and rearrange it. From there, I get t equals x over 30 cos theta. So, and I'm going to substitute this into y to find the Cartesian equation, and you'll see why in a moment. So let's go through this process. So sub t equals x over 30 cos theta into y equals minus 4.9 t squared plus 30t sine theta. So that will give me, let's come back here, y equals minus 4.9 x over 30 cos theta squared plus 30. Now, how will I write this one? Let's just think about it for a second. Oh, we'll leave it as is. Bracket x over 30 cos theta sine theta. So when I look at this now, what am I going to do? I need to tidy it up a bit. So it's going to equal, come back over here a little bit further. Now, I'm going to get an x squared, and I'll get a 30 squared cos squared. So I'm going to get minus 4.9 x squared over 30 squared is 900 cos squared theta plus, now when I look at this next bit, 30 and the 30 cancel, sine over cos is tan, so I just get plus x tan theta. Now for this next bit, if I move this cos squared up to the top, it becomes a sec squared. So I'll do that. Minus 4.9 over 900 x squared sec squared theta plus x tan theta. But we know that sec squared is 1 plus tan squared. So we get that value there. And now we're going to have to expand the bracket. This is going to times to the 1, then it's going to times to the tan squared. And we'll end up with minus 4.9 x squared. I want to do the tan squared first. I'm actually going to do this part first. And you'll see why in a moment. So I get minus 4.9 x squared over 900 tan squared theta. Then the next bit I'm going to do is I'm going to write this bit down, which gives me a plus x tan theta. And the last part I'm going to do is times that by 1, which gives me the minus 4.9 x squared over 900. Now, when I look at that, that's what y equals. But if I come over here, that point there is the point out 80, up 1.5, and I know it's a point on my curve. So I know that when x equals 80, y equals 1.5. So I can actually plug that in, because that's going to just clear the fence if we say that, which means I get 1.5 equals minus 4.9 over 900 times, so we'll go minus 4.9 over 900, 80 squared, 10 squared, plus 80 tan theta, minus 4.9 over 900, 80 squared. That looks particularly messy. Let's see what we end up generating. So we're going to get equals minus 4.9 over 900 times 80 squared. If you put that into your calculator, you'll get minus 1568 over 45. And that will be tan squared theta. Plus 80 tan theta. Now, put minus 4.9 over 900 times 80 squared into your calculator, and while you're doing that, once you've done that, then minus 1.5 to it, which means I'll end up with a 0 here. And when I take the minus 4.9 over 900 times 80 squared minus 1.5, that will leave me with 3271 over 90. So, next thing I'm going to do is multiply each term by 90, because that's the number that's on the bottom of the fraction. I could go over 45, but 90 is the biggest number, and it's common to 45 and 90. So 0 times 90, 90. 0 times 90, 0. Next one, minus 1568 over 45, times it by 90, and you will get minus 3136. Tan squared theta plus, now times the 80 by 90. If you times 80 by 90, you get 7,200. And for our last term, we times by 90 and we're left with 3271. Wow, now we're getting there and I'm running out of room, so what I'm going to do is come over here and I'm going to create some space. So let's solve this. Now instead of having an x, we have a tan squared theta and a tan theta. So I'm going to use the quadratic formula, but instead of writing x equals, I'm going to write tan theta equals. Now it's minus b plus or minus the square root of b squared minus 4 times a, which is minus 3136, times c, which is minus 3271, all over 2 lots of a, 3136. That looks particularly messy. Let's put it into the calculator and we will get two answers. The first answer will be 0.6237, 819064. And the next one will be 1.67213, 6461. Now I don't want to know what tan theta equals, I want to know what theta equals. So let's take the inverse tan of both of these. The inverse tan of 0.62378190064 is 31.955 degrees. Make sure you're in degrees mode, not radian mode. The inverse tan of 1.672136461 is equal to 59.119 degrees. Which means this: when we hit the softball, in order to clear the fence, the angle, it could go up high and down like that, it could go low, could be in between, but in order to clear the fence, we say, to clear the fence, the softball is hit between 31.9 degrees, or 955 degrees, and 59.119 degrees. There's our answer. If it's hit at exactly those angles, it's going to basically touch the top of the fence. Just there's the higher one, there's the lower one. There's the example. You're now ready to try some questions, enjoy the experience. Some of them can get very challenging, but small steps, and see how you go. Enjoy. Bye for now. And if you need a tissue to cry and weep because you finished the course, that's okay.